We have seen that when we place a material like copper in a solenoid, the net magnetization reduces. That is, the copper magnetizes itself by induction in a direction opposite to the solenoid magnetization. So, in a sense, it goes reverse to the external field. In diamagnetism, chi, the magnetic susceptibility, is less than 0. But what causes this to happen? Diamagnetic atoms have paired electrons in their valence orbitals. Their opposite directions of rotation cause their magnetic moments to cancel each other. Something very interesting happens when we place this in an external magnetic field. So let's see what happens in the next step. The moment a diamagnetic material is placed in an external field B0, the electron whose magnetic moment points in the direction of B0 now rotates at a slower speed, and the electron whose magnetic moment points in the direction opposite to B0 rotates at a faster speed. This causes the net magnetic moment due to the electrons to point in the direction opposite to the external magnetic field B0, thereby reducing the net magnetic field to a value below that of B0. So this is the reason you see the magnetic moments of a diamagnetic material in a direction opposite to the external magnetic field. Why one electron spins faster and the other slower, you will learn in the electromagnetism chapter under Lenz's law. So this is a case of a diamagnetic material in an external magnetic field. Let's assume that all the magnetic moments are pointing to the left just for the sake of simplicity. What we want to see here is if we pin down this piece in the external magnetic field and not let it move, we know that the magnetic moments inside have aligned in an anti-parallel manner. But what about the magnetic field lines? Do they remain straight? There is a tendency of the field lines to curve out of the material as shown. The central field line will remain unaffected, but the field lines already outside the material will not be much affected, but the field lines passing through the material will have the tendency of being repelled or pushed out. If we do not pin down this diamagnetic material, then there is a tendency of the material to realign itself, and we will see that in the next lesson. For a superconductor, none of the external field lines will pass through the material. They would all be repelled.